and we have session 6. So expert for session 6 is Professor J.L. Bagoria. Professor Bagoria is professor in Mechanical Engineering Department at MNIT Bhopal. Professor Bagoria has done his PhD from IIT Roorkee. In MNIT Bhopal, he has served at various administrative positions like Head Chemical Engineering Department, Head Mechanical Engineering Department, and recently he has completed his tenure as Dean Student Welfare. So Professor Bagoria research interests are in the fields of experimental fluid mechanics and heat transfer and computational fluid dynamics involving solar energy and heat transfer enhancement. Professor Bagoria is having more than 50 papers in international journals of repute, and he has already guided 12 students for the PhD and more than 75 students for the MTech dissertations. So I welcome Professor Bagoria for today's expert talk. So Professor Bagoria will be giving his expert lecture on recent advances in solar energy. So over to Professor J.L. Bagoria for his expert talk.
Thank you, Professor
Welcome,
Adnan,
sir.
for my brief biodata for the audience. Now I can share these slides now. Okay, we'll
Okay,
start.
you can start. Go ahead. Everything is visible, huh? But you can just press this hide button so that it doesn't show. Hide, huh? Hide. You can press this hide button. That's fine. Now you can go ahead.
Slide is visible to you?
अच्छे से visible है. Everything is coming.
Yeah, yeah. Now shall we start?
Go ahead, sir.
Yeah, yeah. Okay, good evening, all of you, dear participant for this faculty development program at NIT Srinagar. Already Professor Adnan introduced me. Myself, Dr. J.L. Bhagoria, I am professor in Mechanical Engineering Department, MNIT Bhopal from last 30 years. Okay. Actually, I am working in the field of solar energy because you well known that our near future is totally on renewable energy because we have very good potential of renewable energy in India. That's why I am selected this topic for the coming audience and for the new researchers for this FD program. Okay. Now, basically, the industrial revolution, which began with the discovery of steam engine in 1700, brought about a great many changes. For the first time, men began to use a new source of energy, which coal in large quantities. A little later, the internal combustion engine was invented in 1870, and the other fossil fuels, oil and natural gas, began to be used extensively. A new source of energy, nuclear energy, came on the scene after the Second World War. In the past few years, it has become obvious that fossil fuel resources are fast depleting and that the fossil fuel era is gradually coming to an end. This is a particularly true for oil and natural gas. It will be useful, therefore, to first examine the rate of consumption of the different sources of energy and to give some indication of the reserves available. Therefore, the need of alternative energy option will thus be established for the coming year. Now, this is one quote given by Bhavishwatra Puran by the book of Solar Energy Principle of Thermal Collection and Storage by Thermal Professor S.P. Sukhatme. The quote is, always focus your attention at the center of solar system when the sun, the supreme power of the universe, resides. Now, outlines of my presentation is need of solar energy, what is energy crisis, then emission and global warming, then scope of solar energy, then future of solar energy. In scope of solar energy, we have water heating, space heating, power generation, refrigeration, and air conditioning, distillation, drying, cooking, and photovoltaic. Now, future of solar energy, plastic water space heater, use of advanced vapor absorption cycle, and high temperature collector. Then power generation using organic Rankine cycle, tri-refrigeration, concentrated PV system. And then in the last, I go with experimental investigation on solar air collectors. Now, what is energy scenario in India? Actually, sector-wise energy consumption in India, that is domestic, we have 21%, industry 30%, then transport 42%, hydrocarbon industry 6%, other 1%. Higher the consumption, better the living standard. Per capita annual energy consumption in USA 6% population, this is 12314 kilowatt hour, 22% energy. In India 17% population, 2.6% energy. Then global average approximately 3 times of India. Then Asia average 922 kilowatt hour, approximately 0.17 times of India. Now electric power generation. Still, you well known that in India, still we have generating our power with the help of thermal power plant. Still the generation from thermal power plant is 57.4. This is some old data, but near about 55 to 60% still we are generating our power with the help of thermal power plants. Now few from hydro, this is 11.38%, few from renewable energy sources. As on today, from renewable energy sources, we are generating around 24% of power from the renewable energy sources. So from this data, you know well known that still we are generating our power, this thermal power from thermal power plant, that is around 60%, because we have tremendous amount of coal available. But uh, for this is for only 100 or 150 years. So we'll go for the alternative fuels also. Now, energy crisis. Actually, in previous in 1923 or in 1973, there was the and we call as the energy crisis. Then this energy resources: oil 38%, coal 28%, gas 21%, nuclear 6%, and now what is oil crisis? In 1973, when the oil prices, very well you know, the oil prices controlled by the Organization of Petrol Exporting Countries, OPEC. This whatever we are getting oil in all the countries, this is totally controlled by the OPEC. This is one society we call as Organization of Petrol Exporting Countries. Now in from 1973 we call as a energy crisis, and generally we call as a first oil shock in 1973. Then oil prices shoot up. In olden days, what happened when the prices boom for 1 rupees, 2 rupees, 3 rupees, 10 rupees, we call as a oil shock. In 1973, this was we call as a first oil shock. Then oil prices shoot up. Next oil shock in 1970, 1990, 2000, and 2000. But nowadays, you see daily this 50 paisa, 25 paisa is increased. So nobody is thinking that this is the oil shock. But in 1973, when we are facing the problem of energy crisis, that time we call as a oil shock. So that's why in 1979, then 1990, 2002, up to 2011, when the price is increasing, the public from India, they are called, this is the oil shock, while they are increasing 10 rupees, 20 rupees, 30 rupees. But nowadays, daily, the change of prices from the oil. Okay. Then availability of fuel. Coal reserve 75 billion ton. This is third largest, last for next to 38 years. Then crude oil reserves 300 million ton, last for next 18 years. Then natural gases reserve 1000 billion meter cube, last for 26 years. Then 63% of oil requirement are met through imports. Then hydro resources, total potential, this 1 lakh megawatt, this is 17th in the world, installed 46,850 megawatt. Then hurdles, huge installation cost, environmental and social problems. Now, natural resources, plan to reach 10,000 megawatt by 2012 and 20,000 megawatt by 2022. Then thorium reserve, this is 4,50,000 ton, 60% of the world. Then India has installed 17 pressurized heavy water reactors. Now, before I start on the what is going in the solar energy, before we you see the recent developments and one experimental work we have done in the solar collector, before that I go through one short analysis, because whenever you can design any product for to sell in the market, you go for the short analysis. And this short means strength, weakness, opportunity and threat. So first we'll discuss, because among all the renewable energy sources, जितने भी हमारे renewable energy sources हैं, solar energy is one of the biggest source of renewable energy sources. Without solar energy, we cannot run other sources of the renewable energy. So solar energy is one of the main source of renewable energy. That's why before going for details in the solar energy, first we do the short analysis. Or for any development of product, for any development of this renewable energy park, for any development of industry, first you can do the short analysis. Without short analysis, you cannot be success for any company or any renewable energy project or anything in the mechanical engineering. So this short means strength, weakness, opportunity and threat. For any concept or process we propose in the case, also short analysis is necessary, so that analysis shall be considered right at the planning stage. Because when you are doing planning, you go for the short analysis. And this is the prototype model for everything. You can, in your life also, you can do your short analysis for planning in the future. So this is common to all. This is a prototype model. You can apply anywhere, in your personal life also, in your studies also, in your industries also. So this short means strength, weakness, opportunities, and threat. Now we'll start from strength. What is the strength of solar energy in India? Now, this source of energy is inexhaustible. You very well known this. In India, the potential of solar energy is very good. Okay. Out of 365 days, we have 330 days of solar radiation in India. This is the beauty of our India, because we have very good potential of solar energy in India. That's why, and this source of energy is inexhaustible from the nature. वो कभी भी खत्म नहीं होगा ये वाला source. That's why among all the renewable energy sources, solar energy is one of the main source of energy. That's why we call source of energy is inexhaustible. And this in India, we have very good potential of solar energy. Out of 365 days, we have 330 days of solar energy in India. Now, so this is the second strength. This is totally pollution free. There is no pollution when you are using the solar energy product. Then can be utilized for all purpose, can be utilized in any form of energy. Then scope of decentralization, easy to operate, minimum working expenditure, safe fossil fuel deposit, economical self-sufficient, and less hazards. So whenever you going for any power plant development, suppose you go for the solar power plant development, so first what is the strength of solar energy in the state, in the country. So then you go for the solar energy power plant. Suppose in India, if you go for wind energy product, so you go for short analysis of wind energy also. कहाँ पे हमें wind energy का potential ज्यादा नहीं मिलेगा, then we install our wind power plants. ऐसे ही हमको solar energy में देखना है कि in which state we have very good potential of solar energy. like this hydro. Suppose you are in Srinagar, in Ladakh, then we go for the hydro energy projects. We first we see which potential is easily available in these states. That's why in solar energy also, first we see where is the this potential is easily available, and throughout the year this source is available. So first we see the strength. You can apply this model anywhere. First you think about the strength of your uh, this development of product or plan in the planning stage. So this is the strength of solar energy. Now second is the weakness. Everything, every product, anything that having weakness also, but we are not showing weakness. Sometimes we are only showing the strength of the system, but we'll think about the weakness also. So weakness of the solar energy, the main weakness of solar energy, that is problem of storage. You know very well, we are facing the problem of storage, how we can store the solar energy. This is the main weakness of the solar energy. Now, second point is not available on cloudy days, because whenever we are selling any product to the customer, the problem from the customer side, sir, this solar energy is available for limited time. What we do when this is not available in the cloudy days? So nowadays we are develop the hybrid system, but this is the weakness as come from the customer side. This not available on the cloudy days. But in the first slide I show in India, in Madhya Pradesh, Gujarat, Maharashtra, Rajasthan, we have this solar energy. Out of 365 days, we have 330 days of solar energy available in few states. Only for 1 month we are facing this not available on cloudy days. Okay. Then quantum varies according to season or weather. Then initial investment is very high. Whenever you are discuss for renewable energy प्रोडक्ट, आप कोई भी रिन्यूएबल एनर्जी प्रोडक्ट का मार्केट से परचेस करेंगे, कुछ भी करेंगे, every customer says the initial investment is very high. Suppose you go for a wind turbine power plant. Okay, you know, one wind turbine cost, those available in Tamil Nadu and Madhya Pradesh also, in some seashore they are installed also. Generally, minimum cost of one a single wind turbine is about 8 crores rupees. And like this also, this power plant, solar power plants also, initial investment is very high. That's why the customer is saying, sir, initial investment is very high. कोई भी हम renewable energy का product लेते हैं, either we are taking solar power plant, solar water heating system, solar air heater system, then wind turbines, the initial investment is very high. But we'll say to the customer, the payback period is very short. But as this weakness comes from the customer side, that's why I'm showing these are the following weakness. Now next is the need subsidy. This is very important. In this 1990, when this renewable energy products are coming in the market, then every states wants subsidy. This is one big disadvantage of our country. They want in every product, they want subsidies. A very good example of your domestic this cooking cylinder available in the market. Earlier, this cylinder is available in this subsidized age. From last 5 years, this subsidized is only for the uh, lower wages peoples only, or some those who are not afford this all this cylinder cost. Then they get. But in the previous years, this subsidy to the everyone, those who are getting 1 lakh salary, 2 lakh salary, 3 lakh salary, 10 lakh salary, this is not dependent on the wages. Everybody is getting subsidies on this cylinder. But from last 4 5 years, this subsidy is stopped. Like same in renewable energy products, every states want subsidy from the government of India to install this power plant in their state. हर स्टेट वाला बोलता है सर इसमें हमको सब्सिडी दीजिए. So this is the one of the weakness of the system. What happened in the olden days? Suppose some state are non, they are under development. Suppose Jharkhand, this many state, not I am saying the name of this state, but they want subsidy because they are condition, they are under development condition. So suppose government of India gives subsidy to the Madhya Pradesh is 50%. For Andhra Pradesh, they are giving 70%. At that time, there is no common subsidy to all. There is a different way of subsidy. Somebody is getting 50% subsidy, some are getting 60% subsidy, some are getting 70%. It depends on the development of the state, and this like this. So this is one of the weakness of the renewable energy product. Everybody wants subsidy. Now then, next weakness is spares not easily available. This is one of the major problem of the renewable energy product. You are not getting spares easily available nearby your house. Suppose we have very small solar cooker at your home. In maximum Maharashtra, Madhya Pradesh, Rajasthan, in 1990 there is a huge supply of solar cooker in the market. But what happened after 4 5 years, when there is a problem of glass, there is a problem of gasket, there is a problem of this equipment. So we are not found any shop near to the city. Still, you found only 2 3 shops in the capital place of the state. So spares is not easily available. So this is complaint coming from the customer side. Sir, कहाँ से हमें spares मिलेगा? Suppose a simple water heater system installed in the domestic purpose, but after 2 3 4 5 years, we need some maintenance of this water heating system. At that time, you are facing this spare parts for the water heater, spare parts for the solar air, spare parts for the solar lantern, spare parts from the solar photovoltaics, this power plant system. So this is the one of the weakness. So nowadays government giving lot of facility. They are providing easily spares in all the state, in all the small cities. Nowadays this problem is solved, but still we are facing weakness in uh, this not in urban areas, but in rural areas you are find this type of weakness, because you are not getting spares very easily for the this renewable energy. But that's why this comes under weakness. Then creates problem for urban planning, since higher building interrupts lower solar system. Now what happened, this is very important. Whenever you are designing any city, solar city, suppose you are providing solar water heating system for the house. So in what happen in abroad, in US, UK, their urban planning is well planned. Suppose one story means one story, two-story means two-story, then they are installing solar water heating system in the top. Otherwise in our here in India, we are facing the problem of urban planning. Suppose you have a single story house, then your neighbor having double story house, then your other neighbor having triple story. Then what happen, there is a interrupt solar system. Suppose you have solar water heating at your top of the roof, and your neighbor having two-story building and three-story building, then you are facing the problem of solar radiation. That's why whenever you are developing any city, then urban planning city system is required. How much story they are give permission to the this all the society members, one story, two-story, or three-story. So they are well designed. Then they can use proper utilization of renewable energy product. Otherwise, what happen? There is an interrupt of solar radiation in the system. So this is again the weakness in our country. We are not using proper solar radiation for our water heating system, for solar lantern, for solar because the our planning of the society, planning of the city is not well on the same targeted on. Suppose single build roof build single story building or double story building, but we have single story building, double story building, triple story building, and we are facing the problem of solar radiation to our product. Now, the main disadvantage, weakness of the system is still we are facing not yet taken on the priority list. Still, government is forcing every state you go for the renewable energy product, you use wind turbines, you use solar energy, solar power plants, but not yet taken on priority list, because we have very easily this power is easily available in our states. हर स्टेट में अभी भी पावर अवेलेबल है स्टिल वी हैव कोल very huge quantity of coal available in our India. That's why not yet taken on the priority list. This all weakness come from the customers. The first problem of storage not available on cloudy days. Initial investment is very high. Spares not is available. Not yet taken on the priority list. Now, opportunity. First is strength, second is weakness, now third is opportunity. By bringing down the price, it can be boom even for low income group. Then chance of hazard is less, scope for decentralization, then chance of exploitation of energy consumers, totally pollution free, vast opportunity for expansion in many years. These are the opportunities of solar energy. Now, threat. This is very important part for any product or any sources you can reduce or you cannot permit to use common person. Now, threat from the oil lobby. We have very big oil lobby in our country or in world also. If you are going for using this renewable energy product, there is a lot of pressure from the world, lot of pressure from the country. Why you are going for renewable? We have lot of oil available in the world. So this is threat from the oil lobby. They are threatening to the government. They are threatening to the customers. Why this is a lot of weakness in this renewable energy? Why you are not direct purchase this oil? This is easily available. So this is threatening from the oil lobby, and they are pressurized the ministry also. They are pressurized the state customers also. This is we call as a threat from oil lobby. Okay. Now same threat from the coal lobby. You know very well, if everybody using renewable energy, then what is the use of this all the coal mines available in India, all the oil there's a reserves available in the world. So that's why there is a threat coming from the coal lobby. Still we have very good huge amount of potential of coal is available in India. That's why the threats from the coal lobby. Why you are promoting the renewable energy? Because if everybody is using renewable energy, solar energy, wind energy, hydro, and many types of renewable energy in the market, then what is the use of this coal mines and oil? They all are dependent on the this world. Maximum world countries, they are all the revenue come from the oil. In India also, this revenue, most of the revenue they are collecting from the coal plants also. So these type of the many contractors, many this sailors of the coal available in the country, they are threatening to the ministries, they are threatening to the states. Why you are using this renewable energy? Because in what you are doing in the rainy season, what you are doing in the winter season, they are saying lot of weakness of this renewable energy product, and they are saying lot of weakness to the customer. the, these are the weakness of the renewable energy. That's this we call as a threat from the coal lobby and threat from the oil lobby to stop the use of renewable energy products. Then opposition from different forces due to subsidy. Now this is one of the threatening from the opposition from different forces. Everybody wants subsidy. Suppose if we have installed 70-50 megawatt solar power plant in the Madhya Pradesh, so our state government asks subsidy from the central government. Sir, please give me 50% or 60 or 70% subsidy, because we don't have that much of money and our state condition is very poor. So this type of different for lot of different forces are available many private companies are coming in the renewable energy product. So they want subsidy for this renewable energy products. Now lack of knowledge of the common customer. This is one of the biggest problem why we are not enhancing in the field of renewable energy installment, because lack of knowledge of common consumers. अभी भी हमारे देश में किसी को पता नहीं है, कॉमन मैन को पता नहीं है कि हमारे पास कितना पोटेंशियल है रिन्यूएबल एनर्जी का. You can know very well in US, in UK, they have very little potential of renewable energy, but they can take all the potential of renewable energy when there is a sunshine or there is a wind flow. जब भी उनके पास सनशाइन होता है, सन निकलता है, वो उतनी सोलर एनर्जी को कैप्चर कर लेते हैं और यूज करते हैं. इन यूके ऑल्सो जितना भी उनके पास विंड रहता है, वो पूरी विंड को कैप्चर करके दे आर यूजिंग द विंड टेक्नोलॉजी. बट इन इंडिया वी हैव वेरी लैक ऑफ नॉलेज ऑफ द कॉमन मैन. हमारे यहाँ कॉमन मैन को ये पता ही नहीं है कि कौन से स्टेट में कौन सा पोटेंशियल है. सोलर का पोटेंशियल है, हमें पावर प्लांट सोलर का वहां यूज करना चाहिए, बिकॉज स्टिल वी आर यूजिंग maximum power from the thermal power plants. But still day by day this government they are forcing to all the state, you go for the solar energy project, you go for the wind energy project, you go for the hydropower, whatever the source in the state is available, you install that type of power plant. So first, what happened with this FDP program? This is very important. This faculty development program or student teaching development program, to know the knowledge of renewable energy in our India. In our courses also, in many universities, they are running their elective in the solar energy, renewable energy. In most of the university, they are having one elective of renewable energy, because our future is for renewable energy, that is for solar and wind energy. In 10 years, you find that in maximum we are not depend on the oil and the coal. Maximum we are using solar and wind energy. So that's why this knowledge is given to the common customer. How much potential of solar energy? We have 330 days of solar energy available in India. Then why we are only 24% of power generating from the renewable energy, and rest we dependent on the coal and the oil. तो हर आदमी को हमारे पास नॉलेज होना चाहिए कि हमारे पास सोलर एनर्जी कितने सोर्स में अवेलेबल है. तो देन वी कैन यूज इन द रूरल एरियाज में हम बहुत आसानी से हम रिन्यूएबल एनर्जी को यूज कर सकते हैं, बिकॉज वी हैव वेरी गुड ऑफ स्पेस इन आवर हाउसेस. रूरल में हमें स्पेस भी होता है, तो वी कैन यूज वेरी यूज इजिली दिस सोलर कुकर, सोलर लालटेन, solar power plants, and this solar water heating system. Because the person residing in the rural areas, they are having time also. But what happen in urban areas, the customer, they are having very limited. They start their journey of burning from 8 a.m. to 10 a.m. So this is very good utilization in the rural area of this renewable energy product. Suppose nowadays we are using wind energy technology. This wind energy technology, we are generating lot of power from the wind energy, and we supply to the industries. Suppose we have lot of this wind energy from many private sources. They are installed in the hilly areas, they are installed in the sea areas, and with generating this power, they are supplying to the industries. तो will develop knowledge to the common customer कि एक सोलर कुकर हम यदि यूज करेंगे तो हम कितने सिलेंडर सेव कर सकते हैं, यदि हम एक सोलर लालटेन यूज करेंगे तो हम कितनी पावर को सेव कर सकते हैं. सपोज एक हम सोलर वाटर हीटर्स लगाते हैं घर के अंदर, तो हाउ मच पावर वी कैन सेव. Nowadays, the important part in India, this is the solar PV plants of 1 kilowatt, 2 kilowatt, 3 kilowatt, very easily available in the market. You can easily reduce your this unit of your domestic. तो एक कॉमन मैन को हमको बताना पड़ेगा, when you are using this solar energy product, the cost is very high, initial cost is very high, but the payback period is very high. Within 3 years, within 5 years, within 10 years, your full amount is this back to your company. Whatever you are doing, 10,000, 30,000, 1 lakh, this payback period is only 5 years, 3 years or 10 years, not more than this. तो हमें एक कॉमन कस्टमर को बताना पड़ेगा कि कितना यूटिलिटी है रिन्यूएबल एनर्जी का प्रोडक्ट. एंड दिस इज पॉल्यूशन फ्री आल्सो. We are facing, our country is facing from pollution also. You see this all the urban areas, we are facing the problem of pollution also. So with the use of this renewable energy, we also reduce the pollution of the problem. Now then, fluctuation due to season or weather may discourage customer. Now there is a threat from the uh, oil lobby, coal lobby, and those who are not interested to develop the renewable energy product, or those who are not interested to enhance the renewable energy facility in India, they are discouraging our customers. They are saying the lot of what you are doing in the winter season, what you are doing in the rainy season, but no, we have tremendous solar energy, wind energy. We go for hybrid system. So we say for a common man and a common customer, suppose you are facing for solar energy, you go for wind energy. So now this hybrid system is also available in the market. So this is all about the short analysis of for the solar energy. Whenever you are doing any work, this is the prototype model. You can apply anywhere when you are planning for any industries, for any power plant. First you see the strength, what is the strength of your product, then what are the weakness of your product, then what are the opportunities, and then last is the threat. So this we call as a short analysis. Now, then, merits and demerits of conventional energy sources. What are the merits and demerits of conventional energy sources? Cheap at present, cost will shoot up by the law of demand and supply, easy of storage, convenient to use. Now, demerits, pollution, CO, CO2, NOx, particularly matter. Coal is used for chemical, pharmaceutical, and paint industries also. Nuclear plants, disposal of nuclear waste, sophisticated technology. Hydroelectric plants, deforestation, ecological disturbance, rehabilitation. Then greenhouse effect and global warming. Now, greenhouse effect, CO2 envelope prevent escaping of long wave infrared radiation, thus prevent escaping of heat. Normal concentration of CO2 in the atmosphere 0.03%. Other greenhouse gases, methane, nitro oxide, HFC, S2 vapor. Then what are the consequences of global warming? Increase in global temperature, melting of polar snow caps, then frequent and severe heat waves, intense cyclones, change in rainfall pattern, increase incident of vector borne decrease like malaria. Then what are the solution to the problems? We go for energy conservation, judicious use of energy, energy efficient appliances, heat and electric operated, waste heat recovery, hot water, air application, refrigeration, air conditioning by absorption cycle, then use of insulation. Then other solution of this problem, explore other sources of energy we call as a non-conventional or renewable energy. That is solar, thermal and PV, thermal, solar thermal energy, thermal photovoltaic energy, wind, biomass, mini and micro hydropower plant, geothermal, ocean, wave, and this type of technology for the solution of this problem. Now, features of renewable energy sources. What are the features of renewable energy sources? The important thing, this is free of cost. You will not pay any cost for this solar energy. Then environmental friendly, inexhaustible, and low energy density. This is the beauty of this solar energy product. Now the first feature is free of cost. You are not pay any cost for this renewable energy sources. And environmentally friendly, inexhaustible, low energy density. Solar and wind, wave, tidal, biomass, geothermal, coal, power cable. Then uncertainty of availability, difficult to transport. Then what are the scope of solar energy? एक कॉमन मैन को पता होना चाहिए, वी डिवाइडेड दिस सोलर एनर्जी इन टू पार्ट्स एक्चुअली. जो सोलर एनर्जी है कॉमन ले मैन को जो भी होगा, whether it is from electrical side or mechanical side, we divided it to two parts. First is solar thermal and second is solar photovoltaic. Generally what happened, this mechanical student, most of the mechanical student, they are working in the field of solar thermal, and in solar photovoltaic most of the electrical student, they are working in the field of solar photovoltaic. But nowadays we are developing the global engineer, you know, electrical also, you know, electronic engineering also, you know, computer science engineering also. Nowadays there is no meaning of mechanical and electrical, you or global engineering. So you know thermal also, you know photovoltaic also. But in books, we divided this portion into two. We go for solar thermal and we'll go for solar photovoltaic. Now in solar thermal, we have water heating system. Generally, आपने देखा होगा घर में we call as a solar water heating system. This is domestic and industrial type. We have two types of water heating system, one for domestic and other is for industries. Now, the weakness, I tell in this short analysis, the weakness of renewable energy or you call it a solar energy, the initial investment is very high. Okay. When you go to purchase for purchasing a solar water heating system in the market, the cost of one water heating system, it starts from 50,000. Then the customer say, sir, the cost of the water heating system is very high, 50,000. This increases from 50,000 to 1 lakh. Why? Because the solar water heating developed by the organization, the range of temperature they are giving from 50 degrees centigrade to 70 degrees centigrade. And the same water heating system they are using for the domestic and for the industrial applications. क्या करते हैं ये लोग जो वाटर हीटिंग हमारा सिस्टम बना है, व्हाई देयर कॉस्ट इज वेरी हाई? बिकॉज देयर टेम्परेचर रेंज इज फ्रॉम 50 टू 70 डिग्री सेंटीग्रेड. Now you very well known, for a bathing, how much temperature we required in the solar water heater system? 25 to 30 degrees centigrade is too much for bathing purpose. And our solar water heater system is given 70 degrees centigrade temperature. That's why whatever the material they are using, they all sophisticated material and which gives up to 70-degree temperature. So suppose a common man, if he can install his solar water heater system in his own industry, or a simple fabricator, he can install a solar water heater system for domestic purpose, whose temperature range is required from 25 degree to 35 degree, then the cost will reduce. It comes around 15,000 to 20,000. Or in some places, you can also reduce the cost of your solar water heating system where solar potential is easily available. Suppose in Madhya Pradesh, Maharashtra, in Rajasthan, so we have very good potential of solar energy. So in this solar water heater system, we also not required this shell also for storing the water. But in Srinagar, in Ladakh, where temperature range is very low, so the cost of the system is something high because we are this storage of hot water is also required. So it depends on the application of the solar water heater system. But in market, the cost is very high, 50,000 to 1 lakh. But if you can design a mechanical engineering design for his own house, he can design easily in 15,000 to 20,000. Because the range for bathing purpose, the temperature required is 25 degree to 35 degree centigrade. क्योंकि जो वाटर हीटिंग हमें मिल रहा है मार्केट में, उसकी रेंज है 50 डिग्री से 70 डिग्री, और वो हमें ज्यादा रिक्वायरमेंट नहीं है इतने टेम्परेचर की. बिकॉज इन हाउसेस वी आर यूजिंग फॉर bathing purpose, for washing of clothes, or sometimes we are using this water for cooking purpose also. If you go for industrial purpose also, then it's okay, 70 degrees centigrade, 80 degrees centigrade. So our textile industries, they are using, hospitals they are using, in industries also they are using big water heating system. Those will given the 70 degree to 80 degrees centigrade temperature. Then second application is space heating. First is water heating. There the fuel is water. Then second solar thermal application is space heating. Here we are using this active and passive techniques for the space heating. Then third application is solar distillation. Then fourth application is drying, cabinet and forced circulation type. Here we are drying the agriculture product. Okay. Many cabinet and forced circulation type of solar air heater is available for the drying of agriculture product. This is very good application. In olden days, पहले क्या हम लोग जो पुरानी हमारी जो पद्धति थी, suppose in Rajasthan we have very good amount of chili, जो मिर्च होता है राजस्थान में बहुत होता है, तो उसको हम ओपन ग्राउंड में ड्राई करते थे. बट नाउअडेज वी आर ड्राइंग विद द हेल्प ऑफ सोलर ड्रायर्स. ओके. नाउ सपोज इन महाराष्ट्र, जो आपने ग्रेप्स देखा होगा, अंगूर, ह्यूज क्वांटिटी ऑफ दिस ग्रेप्स इज अवेलेबल इन महाराष्ट्र. तो फॉर मेकिंग इन किशमिश, this solar dryer are used for the drying of this project. Then cooking, this is very common application of solar energy. This comes under solar thermal. This very common application, cooking, box type and community cooking. Generally जो हमारे घर में अवेलेबल है सोलर कुकर, वी कॉल एज ए बॉक्स टाइप ऑफ सोलर कुकर. और जो हम हॉस्पिटल्स, हॉस्टल्स, इंडस्ट्रीज में यूज करते हैं, दैट इज नोन एज ए कम्युनिटी कुकिंग. तो दिस सोलर कुकर इज वेरी इंपॉर्टेंट पार्ट फ्रॉम द सोलर एनर्जी। हमने जो हमारे स्टार्ट करा है सोलर एनर्जी, दैट वी स्टार्ट फ्रॉम द सोलर कुकर इनिशियली इन 1919 in 2000, in huge quantity of government of India supplying the solar cooker, because this is the initial time how we can this how we can solar radiation grabs and how we can use this solar energy, because we have very easily power available, very easily coal available. That's why at that time solar cooker we started, we call as a box type. Now nowadays in every big industries, in our hostels also we are using the solar cooking system. Then third one, the important application is the power generation. Now in Rajasthan, Madhya Pradesh, uh, in Gujarat, we have very good power generation station of solar power plants. In Madhya Pradesh also we have 750 megawatt this solar power plant in Rewa. This is biggest power plant of solar energy. So we are generating good amount of power from the solar energy also in Rajasthan, Gujarat, Maharashtra and Madhya Pradesh. Okay. Then next application is refrigeration and air condition. Nowadays we are run our refrigeration and air conditioning with the help of solar energy. Then solar photovoltaic. Now solar water heating system. डोमेस्टिक, देखिए एक कॉमन मैन को ये पता होना बहुत जरूरी है कि व्हाट आर द कॉमन कंपोनेंट्स ऑफ दिस सोलर वाटर हीटिंग सिस्टम, व्हाई वी आर यूजिंग नॉट दिस रिन्यूएबल एनर्जी। हम मैंने आपको वहां शॉर्ट एनालिसिस में लैक ऑफ नॉलेज टू द कॉमन कस्टमर्स, हमारा जो कॉमन कस्टमर है उसको नॉलेज ही नहीं है कि सोलर वाटर हीटर सिस्टम होता क्या है, सोलर कुकर होता क्या है, सोलर लालटेन होता क्या है, सोलर फोटोवोल्टिक प्लांट्स होते क्या है। इसको हमको बेसिक नॉलेज होना चाहिए जनरल, जैसे हमको थर्मल पावर प्लांट का नॉलेज है कि कोल होता है उससे हमारा पावर जनरेशन होता है, बट नाउअडेज दिस स्मॉल टाइप ऑफ प्रोटोटाइप इक्विपमेंट इज अवेलेबल टू get the solar energy and generate the power. Okay. So now for domestic water heater system, the main component is the flat plate collector. अब आपसे जब भी कोई बात करेगा, we have the important component in solar energy that we call as a collector. कलेक्टर बोलते हैं हम उसको, जो कलेक्ट करता है सोलर रेडिएशन को, जो सोलर रेडिएशन को कलेक्ट करेगा, वी कॉल एज ए कलेक्टर। एंड स्टोरेज टैंक, सोलर रेडिएशन एक कलेक्टर होगा जो हीट करेगा हमारे पाइप्स को, और एक स्टोरेज टैंक होगा जो स्टोर करके रखेगा पानी को एट द इन द मॉर्निंग व्हेन वी रिक्वायर्ड हॉट वाटर, तो स्टोरेज टैंक का हमारा यूज होगा। ओके, नाउ वी हैव टू टाइप्स ऑफ कलेक्टर अवेलेबल इन द मार्केट। एक कॉमन मैन को पता नहीं होता व्हाट डू यू मीन बाय कलेक्टर, तो जो हमारा सोलर एनर्जी का मेन कंपोनेंट है वी कॉल एज ए कलेक्टर। अब यदि लिक्विड है तो वी कॉल एज ए लिक्विड फ्लैट प्लेट कलेक्टर, और एयर होगा तो हम उसको एयर फ्लैट प्लेट। वी हैव टू टाइप्स ऑफ कलेक्टर, वन इज फ्लैट प्लेट कलेक्टर एंड सेकंड इज द कंसंट्रेटिंग कलेक्टर। दो ही हमारे पास कलेक्टर होते हैं, वन इज फ्लैट प्लेट कलेक्टर, जिसका सरफेस बिल्कुल फ्लैट होगा, वी कॉल एज ए फ्लैट प्लेट कलेक्टर, जिसमें 100% सोलर रेडिएशन एब्जॉर्ब करेगा। ठीक है ना, मतलब उसका एब्जॉर्बर एरिया एंड सरफेस एरिया इज इक्वल, दोनों सेम होंगे। जो सरफेस एरिया होगा और एब्जॉर्बर का एरिया सेम होगा, वी कॉल एज ए फ्लैट प्लेट कलेक्टर। एंड सेकंड इज वी कॉल एज ए कंसंट्रेटिंग कलेक्टर। कंसंट्रेटिंग कलेक्टर आपको पता चलेगा, जो सर्कुलर डिस्क आप देखते हैं, आपने देखा होगा घर के ऊपर एयरटेल या बहुत सारे आपके जो भी चैनल्स हैं उसकी एक सर्कुलर डिस्क रहती है, ऐसे ही सर्कुलर डिस्क को हम बोलते हैं कंसंट्रेटिंग कलेक्टर। जो भी आपको सर्कुलर कलेक्टर दिखेगा यू कॉल एज ए कंसंट्रेटिंग कलेक्टर। तो वी हैव टू टाइप्स ऑफ कलेक्टर, वन इज फ्लैट प्लेट कलेक्टर, अनदर वन इज कंसंट्रेटिंग कलेक्टर। अब हमको ये पता होना चाहिए कि हमें कौन सा कलेक्टर कब यूज करना है। ये कॉमन मैन को हमेशा पता होना चाहिए कि हमें कौन सा कलेक्टर क्यों है। When you go for low temperature applications, we have three types of application: low temperature application, medium temperature application and high temperature application। ठीक है ना, हम तीन एप्लीकेशंस यूज करते हैं। एक क्या हो गया आपका लो टेम्परेचर एप्लीकेशन, देन मीडियम टेम्परेचर एप्लीकेशन एंड हाई टेम्परेचर एप्लीकेशन. Low temperature application means the temperature range is below 100 degree centigrade. यदि आपका टेम्परेचर रेंज बिलो 100 डिग्री सेंटीग्रेड है तो यू गो फॉर ए फ्लैट प्लेट कलेक्टर. अब आपको लो टेम्परेचर एप्लीकेशन कौन से है? जिसका टेम्परेचर रेंज इज 100 डिग्री बिलो. सोलर वाटर हीटिंग सिस्टम, सोलर लालटेन एंड सोलर कुकर. देखिए ना, सोलर वाटर हीटर सिस्टम में हमको कितना टेम्परेचर चाहिए? 25, 35, 50 डिग्री सेंटीग्रेड. सोलर कुकर में हमें 90, 99 डिग्री सेंटीग्रेड. लालटेन जितने, तो ये जितने भी हमारे, दे कम्स अंडर लो टेम्परेचर एप्लीकेशन. एंड हियर वी कैन यूज द फ्लैट प्लेट कलेक्टर्स. ओके, नाउ concentrating collector, when the temperature range is higher than the 100 डिग्री सेंटीग्रेड. यदि हमारे 100 डिग्री सेंटीग्रेड टेम्परेचर से हम वर्किंग एप्लीकेशन ऊपर है, वी गो फॉर द कंसंट्रेटिंग करंट. तो एक कॉमन मैन को पता होना चाहिए, सब में इंपॉर्टेंट कंपोनेंट है जो हमारे सोलर वाटर हीटिंग सिस्टम जो भी हम यूज करते हैं इसमें कलेक्टर होता है. और कलेक्टर दो टाइप्स के होते हैं, वन इज फ्लैट प्लेट कलेक्टर, अनदर इज कंसंट्रेटिंग कलेक्टर. Now in domestic water heater system we are using flat plate collector because the temperature range is 50 to 70 degree. मैंने आपको बताया फ्लैट प्लेट कहां यूज करते हैं? when the temperature range is low, below 100 degree centigrade. And auxiliary heating may be provided. Now as far as a weakness of our this solar energy, there is a weakness for this season also. कस्टमर बोलता है कस्टमर बोलता है कि मैं रेनी सीजन में क्या करूंगा, मैं विंटर सीजन में क्या करूंगा. तो नाउअडेज वी आर गिविंग ऑक्सिलरी हीटिंग में बी प्रोवाइडेड. सपोज रेनी हो रहा है तो वी आर प्रोवाइडिंग ऑक्सिलरी हीटिंग. यू कैन डायरेक्टली यूज योर पावर एंड यू कैन रन योर सोलर दिस वाटर हीटिंग ऑल्सो एंड योर सोलर कुकर्स ऑल्सो. तो ऑक्सिलरी हीटिंग में बी प्रोवाइडेड टू रन दिस वाटर हीटिंग सिस्टम. Now this is very small. When you simple design, you can make your water heater system 5,000 per meter square. Now then collector cum storage solar water heater. Collector and storage tank combined in one unit. Generally आप जो भी water heater देखेंगे, there is a collector and one on the top of there is a storage tank. It depend on your location also. Suppose in Maharashtra, in Madhya Pradesh, in Rajasthan, we getting sunlight at 10 a.m. in the morning and this sunrise at 6 p.m. in the evening. So around 8 hours or 10 hours solar radiation easily available in few states. So if we are not using this storage tank, the cost of the solar water heater system is reduced. But for Ladakh, for northern areas like Srinagar, Ladakh, this Kurukshetra and this Punjab, you can go for a storage tank because in the early morning, very few solar radiation available in these states. So that's why this cost depend on the collector and solar storage also. Then cheap than earlier, but less efficient and attain less temperature. Then industrial solar water heater system. Now we have two types of circulation system also there. You very well known, mechanical engineers know what is the difference between forced circulation and natural circulation. Suppose we go for a simple water heater system in domestic purpose, then this is a natural circulation process. This cold water come, it will heated with the help of radiation. जो हमारा heat flux आएगा उससे heat होगा. Then due to temperature difference or due to density difference, this will circulate and we call as a natural circulation also. But in industrial solar water heater system, where is huge cost, suppose in hostels, in hospitals and industries, we go for a forced circulation type of solar water heater system. तो आपको ये एप्लीकेशन पे डिपेंड होगा कि आपको नेचुरल सर्कुलेशन चाहिए कि आपको फोर्स सर्कुलेशन चाहिए. ठीक है ना? Because natural circulation means simple. This inlet cold water is coming, then this is heated with the help of solar radiation, solar flux, then it can circulate due to density difference and this natural circulation is going on. Okay. But for industrial purpose, because suppose for industries, for hostels, for hospitals, we go for a forced circulation of water. Okay, auxiliary heating also there for in this rainy season and winter season. Then second application is solar space heating. Space heating using LFPC, hot water delivered by liquid flat plate collector, exchange heat with air in a separate heat exchanger. Auxiliary heater may be provided. Then space heating using air heater, direct air heating, heat storage using rock or pebbles also. Then space heating by passive method also. Passive method means south wall also act as a storage wall, is double glazed and painted black. Generally, this thumb rule for energy, any solar energy product you can install, this will face to the south. एक कॉमन मैन को ये पता होना कि जितने भी हमारे इक्विपमेंट है सोलर एनर्जी के, हम उसका जो कलेक्टर रहता है या पैनल्स रहता है, वी आर फेसिंग द साउथ साइड फॉर गेटिंग मैक्सिमम सोलर एनर्जी, बिकॉज दिस आवर सन this arises from the east, then it set from the west. तो जो हमारा ईस्ट से चलेगा, ईस्ट, साउथ एंड देन वेस्ट, इस डायरेक्शन में. दैट्स व्हाई दिस साउथ वॉल वी कॉल एज एक्ट एज ए स्टोरेज वॉल, इज डबल ग्लेज एंड पेंटेड ब्लैक. ओके. Now, air circulation through two vents provided at the top and bottom of the wall may not provide same degree of comfort as active heating, but may peak up due to higher fuel cost. Then another application of solar thermal energy is solar distillation and drying. First is the basin type solar stills. Consists of basin with black liner, contains saline water. Output is 3 liters per meter square per day with efficiency of 30 to 35 degree. Then cabinet type dryer. Enclosure with transparent cover, perforated tray for material to be dried. Temperature range is 50 to 80 degree. Drying time 2 to 4 days. Suitable for chilies, grapes, etc. This we call as a cabinet type dryer. Then forced circulation dryer may be direct or indirect type, suitable for crops, timber, etc. Then the main application of this solar energy, this is we call as a solar cooker. देखिए, जो भी FDP, those who are attended, either they are faculty or student, they very well know this, the common knowledge of solar energy, and this is the basic application of solar energy. सोलर कुकिंग है जो हमारा सब में फर्स्ट बेसिक एप्लीकेशन है, जो हमें रूरल एरिया में हमें मैक्सिमम फोर्सफुली प्रोवाइड करना है, because they are having huge amount of time also and huge amount of land also, so they can very well use this type of solar cookers in their houses. So our main purpose of scientists, professors, engineers, they can maximum utility of our potential of India, solar energy, wind energy, जो भी हमारे potential available है energy के, हम maximum उनको, because in every state they are facing the power of power energy. Okay, so with the help of this renewable energy product, solar energy, we can short their problem of power in many states. Okay. And this solar cooking is very easily operated and very important application of renewable energy. Now this box type of solar cooker, होता क्या है? What is this box type of solar cooker? This is a rectangular insulated enclosure with one or two glass cover. आपने देखा होगा, एक नीचे का पोर्शन होता है रेक्टेंगुलर इंसुलेटेड एनक्लोजर, और एक हमारा रिफ्लेक्टर होता है, और उसके हम ऊपर दो ग्लास कवर लगाते हैं. And this inner surface is painted black. जो भी उसके इक्विपमेंट होते हैं, जो यूटेंसिल्स होते हैं, they all are painted black. और जो उसका इनर सरफेस होता है सोलर कुकर का, This is also painted black. Now a common जो इंडस्ट्री डालता है सोलर एनर्जी, रिन्यूएबल एनर्जी जो भी होता है, एक जो कॉमन मैन फैब्रिकेटर सोलर कुकर को बनाता है, सोलर वाटर हीटिंग सिस्टम बनाता है, सोलर लालटेन बनाता है, सोलर पावर पैनल, उसको ये पता होना चाहिए कि जो हम पेंट यूज कर रहे हैं वो कौन सा यूज करना है. बिकॉज मोस्ट ऑफ द टाइम सपोज एक लेमैन जो फैब्रिकेटर होता है वो फैब्रिकेट तो कर देता है, बट द एफिशिएंसी ऑफ द सिस्टम इज वेरी, वो आके फिर बोलता है इंजीनियर से या जो भी साइंटिस्ट हो, सर द एफिशिएंसी ऑफ द सिस्टम इज वेरी पुअर. So the reason why this efficiency, because the paint he is using is not as per the standards. जो हम पेंट यूज करते हैं, वी आर यूजिंग द ब्लैक बोर्ड पेंट फॉर द पेंटिंग पर्पस. हमें जो पेंट यूज करना है वो कौन सा यूज करना है, ब्लैक बोर्ड पेंट. बिकॉज आवर एम इज टू एब्सॉर्ब सोलर रेडिएशन, नॉट टू रिफ्लेक्ट द सोलर रेडिएशन. तो कुछ लोग उसको सिंथेटिक पेंट यूज कर सकते हैं, तो सिंथेटिक एमिशन बहुत ज्यादा हो जाएगा. दैट्स व्हाई द पेंट वी आर यूजिंग दैट इज ब्लैक बोर्ड पेंट, जहां भी हम यूज करेंगे ब्लैक पेंट. नाउ सेकंड इज विदाउट और विथ रिफ्लेक्टर. हम लोगों ने हमें रिफ्लेक्टर भी लगाए, एक रिफ्लेक्टर लगाया, दो रिफ्लेक्टर लगाया. देन दिस टाइप ऑफ सोलर कुकर nowadays we are using for chapatis and puris also. Then community type solar cooker. This consists of flat plate collector with booster mirror to heat oil, hot plate pebbles, bed storage. Attain high temperature, then box type. Then we are, these all solar cooker, they are flat plate collector. Now we are using the concentrating solar cooker also, when the temperature is more than 200 degrees centigrade. Now in market, this concentrating solar cooker is also available. Earlier we have box type of solar cooker having flat plate surface, community solar cooker flat plate surface, but nowadays we have concentrating solar cooker, the temperature more than 200 degree centigrade. Then the important part, this is solar power generation. We are generating solar power also with solar energy. Low temperature system up to 100 degrees centigrade. Then uses FPC with booster mirror, solar pond or solar chimney. Then flat plate with booster mirror delivering hot wire near 100 degrees centigrade, which is used to generate low temperature vapor which execute Rankine cycle. Then working fluid methyl chloride refrigerants. Then cost this. Then we have one application is solar pond also, less costly than flat plate collector, but not cost effective. Then we have solar chimneys also, tall centrally chimney surrounded by circular greenhouse and air turbine at base of the chimney. Then cost is rupees 50,000 kilowatt for large scale. Then medium temperature system, we have 100 degree to 400 degree, uses line focusing advocated type parabolic collector to supply heat to Rankine cycle up to 400 degree centigrade, cost 50,000 to 90,000 kilowatt, generating cost rupees 1.50 to 2.50 kilowatt hour. Then high temperature system above 400 degree centigrade, use paraboloidal disk 2-axis tracking system. Efficiency is 30%, but due to restriction to size of disk, can be used for few kilowatt. Then center receiver system, which uses array of large mirror heliostats, cost rupees 65,000 kilowatt for pilot plant in the range of 0.5 to 10 megawatt. Then another application is solar refrigeration and air conditioning, coupling of vapor absorption cycling with solar collector, appropriate collector for particular cycle. Then coupling of vapor absorption cycle with solar collector, use of solar energy to regenerate liquid and solid desiccant used in the desiccant cooling system. Then use of solar energy to regenerate liquid and solid desiccant used in hybrid cooling system. Then use of solar energy for simultaneous generation of power, heating and cooling. So these all are the application of solar thermal. In previous slide I show we have divided this solar energy into two parts. One is solar thermal and other is solar photovoltaic. Now what nowadays we are very good installation of this solar voltaic system in our India. Government is forcing to all states which are having very good potential of solar energy to promote this solar photovoltaic technology. Now this solar photovoltaic technology, This is direct conversion of solar energy into DC electrical power, which can be subsequently used for the various applications. Now, DC to AC converter may be required. Low efficiency. The main disadvantage of this is the efficiency of the system is very low, 10 to 15%. Then cause this old cost application, water pump, street light, lanterns, and small power plants. Now, nowadays, what happened in those states, we have very good potential of this solar energy. We are installing the small solar PV systems. Now you find in Delhi, Bhopal, Hyderabad, Ahmedabad, in Gandhinagar, in most of the houses, they are providing these solar PV systems of 1 kilowatt, 2 kilowatt, 3 kilowatt, 4 kilowatt. It depends on the load of your house. So this is very important. These 4 5 slides are very important. How you can install solar PV system for your houses, because whenever you are going for the solar PV system installation, first you calculate the load and then number of batteries, and to meet the demand, number of solar panel requires, typical power rating of the application that we use in our daily life. Suppose in our house we have CFL of 6 to 18 rating, fan of 60 watt, tube of 55 watt, and tube of electric choke, this is 40. So first we calculate the total load of our domestic. देखिए, एक कॉमन मैन, एक इंजीनियर, बिकॉज नाउ दिस इज वेरी इंपॉर्टेंट टेक्नोलॉजी इन इंडिया, in most of the urban areas we are using solar PV system, and we are forcing to the common customers also, you can install this solar PV system and the payback period is very high. So how you can install and what is the main requirement of this, and how you can design this is simple model you can design very easily for your domestic purpose. The first important thing, you can calculate the total load of your house. Suppose you have one AC, so this wattage of 600 watt. So first you calculate 1000 watt, 2000 watt, 3000 watt. On the basis of calculation of this load, we can install the solar PV system of 1 kilowatt, 2 kilowatt, 3 kilowatt, 4 kilowatt. Now the assumptions, what we are taken. This is one small case study for the solar PV system. A common man, he can know very well what are the main assumptions is also required. Now inverter converts DC into AC with an efficiency of 90%. Okay. Then battery charging and discharging cycle efficiency is about 90%. Since all the charge cannot be used, so we can take 80% depth of discharge, meaning only 80% of total capacity of the battery is useful. Now, how you calculate the combined efficiency of the inverter and battery? Because these are the important component. आप कोई भी फोटोवोल्टिक सिस्टम आपके घर पे लगाएंगे तो दीज आर द इंपॉर्टेंट कंपोनेंट. एक आपका पीवी पैनल्स हो जाएगा, दूसरा इन्वर्टर हो जाएगा, और तीसरा बैटरी. ये 3 4 मेन कंपोनेंट है जो उसमें हम लगाते हैं. ठीक है. तो द कंबाइंड एफिशिएंसी of inverter and battery we calculated as combined efficiency is inverted efficiency into battery efficiency 0.9, 0.9. This comes about 81%. Then battery voltage used for the operation is of 12 volt and the battery capacity is 120 ampere hour. Now you see, in maximum states from January to June, this sunlight available in a day is 8 hours per day. Mostly for India. कितने आवर्स हमको सनलाइट मिल रही है? 8 आवर्स पर डे. और जो हमारा ऑपरेशन ऑफ लाइट्स एंड फैन उसके लिए चाहिए, वो हम मिनिमम कितना भी कर लें तो वी गेट 6 आवर डे ऑन पीवी पैनल्स. ये कॉमन इंडिया के लिए है कि हमें 8 आवर्स पर डे सनलाइट मिलता है, मोस्टली फॉर इंडिया. बट सपोज हम उसको कम भी कर लें तो विल गेट 6 आवर पर डे ऑन पीवी पैनल्स. नाउ पीवी पैनल पावर रेटिंग इज 40 WP. पीवी पैनल जो मार्केट में अवेलेबल है उसका यूनिट है वॉट पीक. or you call as a peak watt. In operating condition, the actual power of PV module is less. Thus, a factor called operating factor is used to estimate the actual output of PV module. So this is comes around 0.75 into 40 will get 30 WP. जो हमारा पीवी पैनल है इसको हम एक हमारा फैक्टर है उससे मल्टीप्लाई करते हैं तो विल गेट अप्रोक्सीमेटली 30 WP. ओके, and this WP means watt peak gives only peak output of a PV panel. Now, suppose in a house you have two CFL of 18 watt each and two fan of 60 watt each. For 6 hours per day is considered which is enough for a drawing room. Now, a PV system design would require information about what is the total load, how many hours one want to run, the appliances, which PV modules and batteries available for use. What will be the total cost? How much solar radiation available? Now, a solar PV system, जो हमारा simple solar PV system है, we have only 4 steps. ये common 4 steps हैं. एक common man को ध्यान रखना चाहिए for designing a PV system. ये thumb rule है हमारा. First we calculate the load of the house. हमारे घर का कितना लोड है, कितने फैन हैं, कितने ट्यूबलाइट्स हैं, कितने एसीज हैं. तो फर्स्ट वी कैलकुलेट द लोड. देन सेकंड, estimation of number of PV panels. मतलब हमको कितने पैनल्स लगेंगे, बिकॉज इन मार्केट this size is standard but different watt peak panels available in the market as per your application. तो फर्स्ट हम क्या करेंगे, whenever we are designing the solar PV system for our house, for our hostels, for our institute, nowadays you see in all the central government institutes, central government industries, government is providing this PV system in all the universities. They run their PV system and they generate power from the solar energy. In all over India you find in maximum universities, maximum government industries, they are providing this solar PV system. You can generate your energy from the solar side. So first is the load estimation. Same for institute also, same for hospitals also, same for hostels also. First you can calculate the load. What is the total load of the hostel? What is the total load of the institute? Then you estimate of number of PV panels. Then third is the estimation of battery bank, and then fourth is the cost estimation of the system. Because cost is very important, because in India everybody first important their discussion regarding the cost. कितना cost होगा हमारे system का यदि हम design करेंगे, तो economical भी होना चाहिए जो भी हम system को design करें. This should be economical also as part of the India. ठीक है. Now first step to design a solar PV system, we can suppose we have 2 CFL, so you can 2 into 18, because this one CFL of 18 watt and then 2 fan of 1 of 60 watt, so will total load is 156 watt only. फर्स्ट स्टेप है हमारा लोड कैलकुलेशन. हमारा लोड कितना आ गया 156, क्योंकि हमारे 2 CFL है और 2 फैन है. एक CFL हमारा 18 वाट का और एक फैन हमारा 60 वाट. तो हमने सब में पहले लोड कैलकुलेट कर लिया. दिस इज 156 वाट. ओके, नाउ टोटल वाट आवर्स रेटिंग, कनेक्टेड लोड इनटू ऑपरेटिंग आवर्स. कितने आवर्स हमारा चलेगा, फैन हमारा मिनिमम कितने आवर्स चलता है, तो भी मल्टीप्लाइड दिस दी ऑपरेटिंग आवर्स. तो हमारा 156 वाटेज आया था, मल्टीप्लाई बाय 6, टोटल वाटेज इज 936 वाट आवर्स. इतना आया. नाउ सेकंड स्टेप, फाइंड आउट द नंबर ऑफ पैनल्स रिक्वायर्ड. अब हमको इसके लिए 936 वाट्स के लिए कितने पैनल चाहिए. 936 वाट मीन 1 किलोवाट. ओके, 936 है मतलब 1 किलोवाट का पावर स्टेशन चाहिए हमको. नाउ एक्चुअल पावर आउटपुट ऑफ ए पीवी पैनल, तो वी कैन, जो मैंने आपको बताया था, जो हमारा पीवी पैनल है एक, उसका पीक रेटिंग है 40 WP. Now we can multiply with our operating parameter. This is 0.75. That equals to the 30 watt. Okay. Now the power available for end use is less. This is actual power output into combined efficiency. अब जो हमारा 30 watt आया है उसको हम combined efficiency से कर देंगे तो approximately we getting 24.3 wattage of our PV panel. This is the final power available for the end use. 24.3 now. Now, energy produced by 140 watt peak panel in a day is actual power output into 8 hours. This is 24.3 into this is 194.4 watt hour. मतलब एक जो पैनल है वो हमारा 8 घंटे में अप्रोक्सीमेटली 200 वॉट हमको सप्लाई देगा. कितना देगा? 200 वॉट. नाउ वी कैन फाइंड आउट हाउ मच पैनल्स वी कैन रिक्वायर. So this solar watt hour rating daily load upon daily energy produced by the panel. तो जो हमारा टोटल आवर्स आ रहा था, हम जो टोटल एनर्जी यूज कर रहे हैं, हमारा जो टोटल लोड आ रहा था दैट इज 936 वॉट. ओके. और जो हमारा एक पैनल है 40 वॉट पीक का उसको हमने यहाँ 8 आवर्स में हमें कितना दे रहा 194. तो वी डिवाइड दिस इज द डिनोमिनेटर. तो दिस कम्स अराउंड 5. तो यू कैन रिक्वायर्ड 5 सोलर पैनल्स ऑफ 40 WP. अब हमको पता चला गया हमारा जो पैनल हमको कितने चाहिए 5 पैनल्स चाहिए इतने पावर जनरेट करने के लिए. तो जब हम 1 किलोवाट पावर जनरेट करना तो वी रिक्वायर्ड 5 सोलर पैनल्स ऑफ 40 WP. ओके. नाउ फॉर ए सिस्टम हायर देन 12 say 12 24 volt, this is 24 by 2. So 2 modules should be used in series to provide 24 volt, while total number of panels should be same. Now then we'll get solar. हमको पैनल्स मिल गए 5. अब हमको बैटरीज भी कितनी लगानी है वो भी हमें ध्यान रखना है. कितनी बैटरीज चाहिए हमको. Now total ampere hour required, total charge to be stored. Battery side should be higher than the actual useful energy due to less combined efficiency of the system. Now total watt hour rating divided by inverter efficiency into depth of discharge into battery voltage. So this comes around 108.33. One can also decide to design a system with 24 volt or 48 volt. Since typical PV panels and battery are designed to give 12 volt, series parallel combination of panels and batteries will be required to get higher PV system voltage. So number of batteries required, this is total ampere hour rating, this is 108 and battery rating is 120. So it comes around 0.9. So we required only one battery for that. कितनी बैटरी चाहिए हमको? एक बैटरी चाहिए. ओके. Now fourth step. Now fourth step is this is inverter. What is the size of inverter? Because this is very important point, inverter. Because you have to convert your DC into AC. तो आपको इन्वर्टर भी लगेगा उसमें. ठीक है. Now inverter rating, this is watt to total connected load of PV panel system is 156 जो आपका था. Then inverter are available. आपको लोड पता है कितना 156 वोल्ट एम्पियर. जो हमारे इन्वर्टर अवेलेबल हैं वो 100 का है, 200 का है, 500 का है. तो हम 156 को हम टॉलरेंस पॉजिटिव साइड में लेके वी गो फॉर ए 26 VA. ये हमारे सब रेंज के अवेलेबल है. तो हमको इन्वर्टर साइज यहां से मिल जाएगा. तो दिस इज अबाउट ऑल हाउ यू कैन this install your solar PV system. ये आपकी रिक्वायरमेंट रहेगी. Now in this way total load and the requirement of number and size of various solar PV system components can be estimated. The example taken here are for a small size house. For designing solar PV system for a large house or for industrial and application similar design approach can be taken. अब आप ये सोच, सिंपल प्रोटोटाइप मॉडल है, you can use for higher design also. Same pattern you can adopt for the higher industrial and higher design also. Now the important point is how cost estimation also. Whenever you are submitting any proposal for this PV system, you can submit cost estimation also. सपोज आपको 100 किलोवाट का जनरेट इंडस्ट्रियल एप्लीकेशन के लिए 100 किलोवाट का पीवी सिस्टम बनाना है, 200 किलोवाट का पीवी सिस्टम बनाना है, 1000 किलोवाट का, तो यू कैन एस्टिमेट द कॉस्ट आल्सो, क्योंकि गवर्नमेंट को आपको टोटल कॉस्ट भी बताना पड़ेगा उसकी। ओके, तो हाउ वी कैन कैलकुलेट द कॉस्ट? कॉस्ट ऑफ द अरे, मतलब नंबर ऑफ पीवी मॉड्यूल्स हमारे कितने रहेंगे। सपोज हमारे इस केस में 5 थे, नाउ 8000 for a 40 watt peak panel at the rate of rupees 200. Sorry, this is 200, so this comes under rupees 40,000, तो इसका आपका पीवी पैनल की कॉस्ट आएगी 40,000. then cost of the battery, it comes around, नंबर ऑफ बैटरी, एक ही बैटरी है तो हमारी उसकी कॉस्ट है 7500. देन एक ही इन्वर्टर है हमारा, तो कॉस्ट ऑफ द इन्वर्टर इज 5000. Now you see the total cost of the system is A plus B plus C. It comes approximately 50,000. This is 50 to 5. So you see this is for 1 kilowatt. तो जो हमारा पीवी सिस्टम है 1 किलोवाट का, उसकी कॉस्ट कितनी आ रही है? 50,000 रुपए. अब आपके पास थंब रूल आ गया है, कोई भी आपसे बोलेगा या आप अपने घर का डिजाइन करेंगे, सपोज यू डिजाइन फॉर ए 2 किलोवाट, तो आप उसको डायरेक्ट कॉस्ट बता सकते हैं कि कॉस्ट कम्स अराउंड 1 लाख रुपीस. सपोज यू गो फॉर ए 3 किलोवाट, तो आप उसको फिर मल्टीपल कर सकते हैं कि 1.5 लाख. 4 किलोवाट अराउंड 2 लाख. तो जितना आप उसको बढ़ाते जाएंगे थोड़ा थोड़ा कॉस्ट रिड्यूस. बट फॉर ए 1 किलोवाट, 2 किलोवाट, 3 किलोवाट, 4 किलोवाट, आप सिंपल सिस्टम से कॉस्ट को निकाल सकते हैं. 1 किलोवाट की कॉस्ट आएगी 50,000, तो 4 किलोवाट की अप्रोक्सीमेटली 2 लाख रुपीस. फिर उसका वायरिंग है, मेंटेनेंस है, एएमसी, वो आपको मार्केटिंग में जितने प्राइवेट सेक्टर है, कोई 3 लाख बोलेगा, कोई 4 लाख बोलेगा, लेकिन आप अप्रोक्सीमेटली डिजाइन कर सकते हैं इसको. ठीक है ना? तो दिस इज गुड फॉर स्टूडेंट प्रोजेक्ट्स ऑल्सो, फॉर एमटेक थीसिस प्रोजेक्ट्स ऑल्सो. इंडस्ट्री का डिजाइन कर सकते हैं, कोई बड़ा हमें प्लांट लगाना, उसके लिए हम डिजाइन कर सकते हैं. बट बिफोर दैट वी गो फॉर ए शॉर्ट एनालिसिस, कहाँ पे हमको लगाना है, सो वो पोटेंशियल हमें कहाँ मिलेगा, सोलर एनर्जी का, विंड एनर्जी का, तो ये हम कॉमन स्टडी करते हैं. और दिस इज वन कॉमन एग्जांपल फॉर सोलर पीवी सिस्टम, क्योंकि ये नाउअडेज हम बहुत यूज कर रहे हैं इसको अर्बन एरियाज में. हर मतलब 10-20% हम लोग यूज कर लें, और विद इन 2030 we go up to 50% of this domestic houses is installed with PV systems. आपको बहुत 50% PV system हर घर में मिल जाएगा. The advantage of this PV system, the payback period is very fast. Within 5 years, all whatever you are invested, this comes back. और फिर आपको उसमें मीटरिंग हो जाएगा, तो जितना आप कंज्यूम करेंगे और बाकी आप जो ग्रिड को देंगे वो आपको रिटर्न भी हो जाएगा, अमाउंट माइनस हो जाएगा. तो जो आपका यूनिट कॉस्ट है वो कम हो जाएगा. इट्स कम्स अराउंड 3 to 4 रुपीज हो जाएगा. तो दिस इज अबाउट द फोटोवोल्टिक डिजाइन ऑफ द सिस्टम. नाउ देन व्हाट इज द इनडायरेक्ट यूज ऑफ सोलर एनर्जी? मैंने आपको बताया वी हैव 2 टाइप्स ऑफ सोलर एनर्जी, थर्मल एंड फोटोवोल्टिक. और रिन्यूएबल एनर्जी में मैंने आपको बताया सोलर एनर्जी इज वन ऑफ द इंपॉर्टेंट रोल among all the renewable energies. Solar energy direct source है आपका, and whatever the other source they call as a indirect source of energy. जितने भी हैं, यदि आपका सन नहीं होगा तो you don't have wind energy, you don't have hydro energy, you don't have bio energy, or you don't have energy. सन नहीं है तो कुछ भी नहीं है. तो that's why we call this is the indirect use of solar energy. जो हम डायरेक्ट बोलते हैं that is solar cooker, solar, ये जो भी solar energy, this is the direct. But these are the following indirect use of solar energy. Then first is hydro energy. This is conventional but clean source of energy. Then wind energy, due to uneven heating of earth's surface, due to uneven heating of Earth's surface and atmosphere and rotation of Earth about its axis and motion around the sun. Then energy from the biomass created due to photosynthesis with use solar radiation. Then wave energy due to interaction of wind with the surface of ocean. Then OTS use of temperature between upper and lower layer of water in oceans. Maximum Rankine efficiency is 5%. Now, what is the present status of non-conventional solar in India? This is old data, but approximately we are enhancing 20% more than this. This is old data. Solar water heating system potential is this, develop this. Then SPV standalone system, itna kilowatt. Then SPV PV system, these all are old data and potential is 20 megawatt per kilometer square. Then wind, this potential, then mini and micro hydro potential, this biomass and sugar industry waste, this, then biomass from urban waste, this bioplants, these all are the potentials. Then solar energy program in India, this solar energy received 5000 trillion kilowatt hour per year, global radiation 5 kilowatt hour per meter square per day, sunny hours this to this per year, solar thermal energy programs. Now, this is run by the Ministry of New and Renewable Energy Sources. We call as a MNRE. जो हमारा मिनिस्ट्री है वी कॉल एज ए MNRE, मिनिस्ट्री ऑफ नॉन कन्वेंशनल रिन्यूएबल एनर्जी सोर्सेस. Then promotion of solar thermal for water oblique space cooking drying, establishment of one unit in solar power Jodhpur. Then solar PV program, this old data. Then this Aditya solar shop, this is very important, you note down this Aditya solar shop. In every state, there in every capital, you find the shop by the name of Aditya solar shop. This is the outlet for sale of solar product. जितने भी आपके सोलर प्रोडक्ट होंगे, बिकॉज हमने जो वीकनेस में करा था ना, दिस स्पेयर पार्ट्स इज नॉट अवेलेबल. So in every state, the shop name is Aditya Solar Shop. Okay. And this is for the outlet for the sale of solar product. Now this is as this old data established in 48, but nowadays around 48 cities this Aditya shop is available, and this spare parts is nowadays easily available in other shops also. So this is the solar energy program in India. So this is all about the recent advances in solar energy. Now this is we generate this experimental investigation on solar collector. This is again new topic. We have developed this solar air collector. With this, we are generating this enhancing the temperature of the air. Okay. Now with this, I can close my topic. If any question regarding this, you can ask. Am I audible?
Yes, you are audible.
Yeah, yeah.
Audience, anyone is having any questions, doubts? I think they will ask in the end because we are.
No, just I close this. First part is over already full because
Okay,
this is again one application for solar electrica.
okay, okay,
So this, I think from my side it's over.
okay, 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 okay. So let you continue with this thing as solar
I show
collector.
a few slides of this also, na solar collectors.
You continue with this thing.
Okay. Now this one experimental investigation on solar collectors. This how we can enhance the efficiency of the solar air collector. Okay. This is my research area. Actually, what happened with the solar air collector available in the market, the efficiency of the solar collector is very less. The efficiency is around 20 to 30%, but we can increase up to 40 to 50 or 60% by the help of some artificial roughness. Now, this application means solar air heater have been observed to have generally poor convective heat transfer coefficient from absorber plate to air. This low heat transfer coefficient result in relatively higher absorber plate temperature, leading to higher thermal losses to the environment and hence low thermal efficiency. What happens in solar air heater? Actually, poor convective heat transfer coefficient from the absorber plate to the air. Okay. For that, how we can increase, how we can improve the convective heat transfer coefficient? This is by artificial roughness has been successfully used for the enhancement of heat transfer coefficient in solar air collector. We are using the artificial roughness, how we can enhance the this efficiency of the solar air collector. The roughness can be in the form of circular, rectangular, chamfer, triangular shape drifts. uh, we are creating turbulence in the laminar sublayer. There is a one laminar sublayer. We can create turbulence in this laminar sublayer, which help increasing the heat transfer rate from absorber surface to air. Now, solar energy collector. A solar collector is a special kind of heat exchanger which collects solar radiant energy and transfer it to fluid, usually water or air. We have two types of solar system. One is solar water, another is solar air. In solar water heater, we circulate water, and in solar air collector, we circulating the air. In the fluid are water and air. And we are using the collector, flat plate collector and concentrating collector. If the area of interception of the solar radiation is same as the area of absorption, the collector is known as flat plate. मैंने जो आपको पहले बताया था, if the area of interception of the solar radiation is same as the area of the, यदि दोनों same है, we'll call as a flat plate collector. Now this is the basic difference between flat plate solar collector. This is schematic diagram of solar collector, and this is a schematic diagram of water heating system. You see this cold water in inlet from these pipes. This solar radiation come from the top side, and this is the hot water outlet. So this is the schematic diagram of solar water heater system, and this is the schematic diagram of this. Now this is the types of concentrating collector, how it look like. This A1 is we call as a flat plate collector. You see the surface is flat like this. This surface is flat, and this is the solar radiation coming on the flat plate surface. Then B, this is compound parabolic collector. You see this is parabolic type. Then C, cylindrical parabolic collector. This is parabolic type. Then third is collector with fixed circular concentrator. Then third is the Fresnel lens collecting conductor. Then main component of the collector, we already discussed what are the main component of the flat plate collector. This normally metallic with black surface, then metal sheets of plate forming continuous surface cooked with radiation, black paint, this metallic oxide, then transparent glass cover. We are using transparent glass cover, which may be one or more. जो हम इस पे ऊपर लगाते हैं, we have two transparent glass cover, one or as the number of glass cover increases, the loss of heat from the top of the collector decreases, while intensity of radiation incident on the absorber plate also. Now in water we have tubes, and in air we have passage. Then in the bottom side we providing the insulation, providing at the bottom and side of the to minimize the heat losses. Then the casing or container which enclose with the component and protect them from the weather. Then liquid heating collector, we'll already discuss. The tubes are attached and has thermal insulation. Then from storage tank passes through the tubes made of metal in the absorber plate, where it picks up heat and flows back to the storage tank. Liquid heating collector are generally used for heating water. Thickness of the absorber plate in such collector, which are mostly made of copper, aluminum and steel, about 1 to 2 mm. Metallic tubes, diameter range is 1 to 1.5 mm, are attached to the bottom side of the absorber plate. by soldering, bracing, and clamping. Copper is most suitable metal because of good thermal conductivity and corrosion resistance. Spacing between the tube range from 5 centimeter to 15 centimeter. This is the diagram for water heater and this is the diagram of air heater. You see here the water tubes are there and here passage is there. This solar radiation come from the top. This is the figure of flat plate solar air collector and this is flat plate water heating system. This in the top we call as a glass cover and this is absorber plate and in the bottom this is the insulation. This. Now, what are the advantage of solar air heater? Solar air heater having certain advantage over other solar heat collector. The need to transfer heat from working fluid to another fluid is estimated as air is being used directly as a working substance. Then corrosion, which causes serious problem in solar water, is completely eliminated. This is the advantage of solar heater over solar water heating system. Then leakage of air from the duct does not possess any major problem. Then freezing of working fluid virtually does not exist. Air heater can be designed using cheaper as well as lesser amount of material and it is simpler to use than solar water heater. Now, what are the parameters of thermal performance of collector? कौन से हमारे ऐसे इंपॉर्टेंट पैरामीटर हैं जो परफॉर्मेंस को अफेक्ट करते हैं? जब भी हम कोई भी सोलर सिस्टम लगाते हैं, there are some parameters which affect the performance of the collector. The performance of solar collector is a complex function of various parameters can be classified as system parameter. सब में पहला we call as a system parameter, then operational parameter and third is the meteorological parameters. ये सब पैरामीटर इस पे आपकी परफॉर्मेंस डिपेंड करती है कि एफिशिएंसी कितनी है सोलर कलेक्टर्स की. Suppose what is system parameter in solar air collector? Number of glass cover. आपने कितने ग्लास कवर लगाए? एक, दो या तीन, जो भी लगाए, बट नॉट मोर देन 2. देन ग्लास कवर एमिसिविटी, सेलेक्टिविटी ऑफ एब्जॉर्बर सरफेस, प्लेट स्पेसिंग, कलेक्टर टिल्ट. ये बहुत इंपॉर्टेंट पैरामीटर है. यू सी दिस थर्ड वन, कलेक्टर टिल्ट. आपने उसको कितने पे टिल्ट करा है? जनरली आपने देखा होगा आपके वाटर हीटिंग सिस्टम होता है, एयर हीटिंग सिस्टम होता है, इस पे एक कलेक्टर रहता है जो पैनल्स को हम बोलते हैं, उसको आपने कितने पे टिल्ट करा है. ठीक है, तो दे ऑल डिपेंड ऑन लॉन्गिट्यूड एंड लैटिट्यूड ऑफ द प्लेस. जो भी लॉन्गिट्यूड और लैटिट्यूड, सपोज भोपाल के लिए डिजाइन करना है तो उसका टिल्ट एंगल अलग होगा, हैदराबाद के लिए डिजाइन करना होगा तो टिल्ट एंगल अलग होगा, श्रीनगर के लिए डिजाइन करना है तो उसका टिल्ट एंगल अलग होगा. It depends on the longitude and latitude of the place. So this we call as a system parameter. Then operational parameter. Operational parameter कौन सा फ्लूइड है उसके अंदर, इनलेट फ्लूइड टेम्परेचर कितना है और फ्लो रेट के अनुसार. Now one important thing, operational parameters. जो भी हमारे सोलर एनर्जी के प्रोडक्ट हैं, they all work at low Reynolds number. दिस इज वेरी इंपॉर्टेंट थंब रूल. जो भी हमारे हैं ये क्या करेंगे? लो रेनॉल्ड नंबर पे वर्क करेंगे, हाई मास फ्लो रेट पे नहीं वर्क करेंगे, क्योंकि जितना लो फ्लो रेट रहेगा उतना हीट वो एब्जॉर्ब करेगा. ठीक है ना, ये बहुत इंपॉर्टेंट थंब रूल है. दे ऑल वर्क एट लो रेनॉल्ड नंबर. ओके, तो दीज आर ऑपरेशनल पैरामीटर, इनलेट फ्लूइड टेम्परेचर एंड मास फ्लो रेट टेम्परेचर. देन मेट्रोलॉजिकल पैरामीटर, किस पे हमारा पूरा सोलर एनर्जी का जो प्रोडक्ट रहता है वो डिपेंडेंट रहता है. इंसिडेंट सोलर रेडिएशन, कितना सोलर रेडिएशन हमारा प्रोडक्ट एब्सॉर्ब कर रहा है. देन कभी कभी विंड स्पीड बहुत ज्यादा रहती है जो सोलर रेडिएशन को कम कर, टेम्परेचर को कम कर देती है. देन थर्ड पैरामीटर मेट्रोलॉजिकल इज डस्ट ऑन द टॉप कवर. यदि आपके पैनल्स के ऊपर डस्ट भी आ जाएगा तो थोड़ा सा हीट जो एब्जॉर्प्शन है वो कम हो जाएगा. So these are the meteorological parameter we call as a incident solar radiation, wind speed, dust on the top. Now, in our research, we are doing a lot of work in this. How do we enhance? Because the solar air collector, the efficiency is very less. Now, we have developed this setup at Manit Bhopal. how to enhance this efficiency of the solar air collector. We are enhancing the efficiency by providing artificial roughness on the surface. जो एब्जॉर्बर प्लेट होती है उसके हम ऊपर हमने क्या करा है, रफनेस क्रिएट करी है. तो जो रफनेस हमने क्रिएट करी, यू सी दिस इज 90, दिस इज द रफनेस, दिस इज आर्टिफिशियल रफनेस. This is 90-degree broken ribs, this is parallel broken ribs, this is disketed. So these all are roughnesses on the surfaces. ये roughness क्या करती है, it breaks the laminar sublayer. एक laminar sublayer form हो जाती है, जो हमारे सरफेस होता है उस पे एक लेमिनार सबलेयर हो जाती है, और उसके कारण वो हीट को रजिस्ट करती है. उस लेमिनार सबलेयर को हम ब्रेक करने के लिए वी आर प्रोवाइडिंग दिस आर्टिफिशियल रफनेस. For different types of many researchers on V-shaped also, N-shaped also, 45-degree inclined also. So different researcher using different type of roughness to enhance the efficiency of the solar air collector. Now, the objective of the experimental investigation was to generate friction and heat transfer data pertinent to heating of air in a rectangular duct with integral wedge transfer repeated roughness on one wall. The statistical correlation for the Nusselt number and friction factor in terms of roughness parameter have been developed, and the effect of system and the operating parameter on the performance have been discussed. Now our experimental setup consists of test section. Will go directly on the experimental system. Yeah. The flow system consists of, we have a duct, this size is 260 mm, this length, width and height. Then we have entry section, exit section, test section, electrical heater, aluminum plate, blower, aspect ratio, mica sheet, and these are the instrument which is used for the measurement of temperature, airflow measurement, pressure drop in duct and solar radiation measurement. Now this is the schematic diagram of experimental setup. What we are doing first full experimental indoor testing, because when you are doing outdoor setup there is a lot of fluctuation in the solar radiation. तो पहले हम जो टेस्ट करा है हमने वो इंडोर टेस्ट करा है, पूरा इंडोर सेटअप बनाया है, और उस पे सोलर इंसोलेशन जो हमको बाहर मिलता है, सोलर फ्लक्स में उस सेम रेंज को हमने यहाँ टेस्ट करा है. और जो हमारा आर्टिफिशियल रफनेस है हमने देखा है कौन सी आर्टिफिशियल रफनेस से विल गेट द मैक्सिमम हीट ट्रांसफर और मैक्सिमम एफिशिएंसी इन फ्रॉम द सिस्टम, और जिससे हमको मैक्सिमम एफिशिएंसी फिर हमने उसको वैलिडेट करा है आउटडोर सेटअप में जाके. तो पहले जो इनिशियल स्टेज में होता है will develop the indoor experimental setup with same insulation range of solar energy outside in the environment. वही हमने आउटसाइड एनवायरनमेंट दिया सोलर इंसुलेशन, वो हमने कंट्रोल करा है विद द हेल्प ऑफ वोल्ट, वेरिएक, वोल्टेज और मिलीमीटर से इससे हमने इंसुलेशन को कंट्रोल करा है कि इतना हमें देना है. तो यू सी दिस इज द इंडोर एक्सपेरिमेंटल सेटअप. This is the entrance lead we call as a test section. This is entrance length, first one, number 1. Then exit section, this 6th exit section. Then this is our test section, 1640. Then 4th is the absorber plate. This is our absorber plate. Then 7th we have GI pipe. Then 8th is the orifice plate. Then we have inclined manometer, flexible pipe 10, control valve this one, then blower. With the help of this blower we can maintain the mass flow rate in the duct. ठीक है ना, मैंने आपको बताया सोलर एनर्जी के जो भी प्रोडक्ट यूज करते हैं वी आर यूजिंग लो रेनॉल्ड नंबर. तो विद द हेल्प ऑफ दिस ब्लोअर we can maintain the mass flow rate. Okay. Then A for emitter, V for voltmeter. With this we can maintain the heat flux. Suppose outside we get 500 watt per meter square. So with the help of this variac and emitter and voltmeter we can maintain the 500 watt per meter square. Suppose we need 1000 watt per meter square. With the help of this electric circuit, we can maintain the 1000 watt. We have heater is there, one heater is there for heating the system. So this is about the experimental setup for the solar air heater. This is indoor setup. We are doing artificial heating here. Then after getting good results, we can validate outside at the environmental condition. Now these are the instrument we are using for the experimental. We are using thermocouple wires. A thermocouple wire is a transducer that convert thermal energy into electrical energy. In is constructed by joining wires made from dissimilar metals. So we are using here this uh, copper constant type thermocouple wires. Now in earlier case we are measuring this pressure difference also. Okay, so we are using this micromanometer for the pressure difference between the duct, but nowadays we are measuring this pressure. This is by this digital pressure meter is available in the market. With the help of this digital pressure meter, we can measure the pressure difference uh, between the in the duct. Okay. Then in earlier cases, we are measuring temperature with the help of this thermocouple wire one by one. But nowadays we have this data logger. We can collect all the temperature in this data logger. This a temperature data logger, also called temperature monitor, is a portable measurement instrument that is capable of recording temperature. तो जितना भी हमारा टेम्परेचर प्लेट के ऊपर होता है वो हम इसके ऊपर रिकॉर्ड कर लेते हैं. पहले हम लोग सेलेक्टर स्विच यूज करते थे टेम्परेचर रिकॉर्डिंग के लिए, बट नाउ इट इज दिस डाटा लॉगर इज अवेलेबल. तो यू कैन मेजर ऑल दी जितने भी पॉइंट्स पे आपको जितने भी पॉइंट्स होंगे उसको आप सपोज 20 थर्मोकपल वायर पॉइंट्स है तो यू कैन इजीली रिक्वायर्ड इन ए 1 minute or a 1 second. Suppose 100 points are there, you can easily record it. But in previous cases, with the help of the selector switch, 32 channels, 60 channels, 100 channels, we are recording the temperature. But nowadays, this data logger is there. You can easily measure at different points temperature range of the thermocouple wire. Then we are using this YouTube manometer. Pressure gauge is used to determine the pressure drop across the orifice plate, which is having minimum check of this. The manometer limb is filled with water, this tubes. So this type of manometer we are using for the pressure measurement also. Then instrument used in the experiment. मैंने जो आपको बताया जो हम इंडोर टेस्ट करते हैं तो विद द हेल्प ऑफ दिस वेरिएक वोल्टमीटर एंड एमीटर हम उतना हीट फ्लक्स इससे मेजर कर लेते हैं. सपोज हमारा जो सोलर रेडिएशन से आता है 500 वॉट पर मीटर स्क्वायर, 600 वॉट पर मीटर स्क्वायर, तो विद द हेल्प ऑफ दिस इलेक्ट्रिकल सर्किट will maintain the heat flux for the our experimental setup. Now range of parameter for the investigation. किस रेंज में हमने इन्वेस्टिगेशन करा है? जो हमारा रेनॉल्ड नंबर है उसको हमने इन्वेस्टिगेट करा है 3000 to 18000. देन रिलेटिव रफनेस साइज हमारी ये है, रिलेटिव रफनेस पिच ये है, रिलेटिव वेज एंगल इतना है और चैनल एस्पेक्ट रेशियो. तो दीज आर द पैरामीटर वी आर इन्वेस्टिगेटिंग कि रेनॉल्ड नंबर का क्या इफेक्ट आ रहा है, जो हमारे आर्टिफिशियल रफनेस है उसका हाइट का क्या इफेक्ट आ रहा है, और ये सबका इफेक्ट हमने देखा है. और डिफरेंट रिसर्चर also using different parameter to enhance the efficiency of the solar collector. Now this type of rib geometry, ये हमारी rib geometry, suppose this is absorber plate, ये हमारी artificial roughness है, this is wedge type of artificial roughness. तो हमने इसमें pitch भी change करा है, angle भी change करा है, and this is creating because we have destroyed the laminar sublayer. यहाँ बॉटम में क्या एक लेमिनार सबलेयर बन जाती थी, लेकिन ये आर्टिफिशियल रफनेस से वो लेमिनार सबलेयर ब्रेक हो जाती है. तो हमने इसमें पिच का इफेक्ट भी देखा है. देन वी हैव सीन द इफेक्ट ऑफ हाइट आल्सो. तो दीज आर द पैरामीटर व्हिच you can study and you can see which parameter is mostly affected for the enhancement of heat transfer. ये हमारे थर्मोकपल्स वायर लगे हैं 1 2 3 हर 18 नंबर ऑफ थर्मोकपल वायर लोकेशन पे. इस थर्मोकपल वायर का विल मेजर द टेम्परेचर विद द हेल्प ऑफ डाटा लॉगर। ये हम आउटपुट में मेजर कर लेते, चार पांच हमने थर्मोकपल वायर लगाए, लोकेशन ऑफ थर्मोकपल वायर। ये हमारे अलग अलग सेक्शन है इसके। फिर हमने इसको वैलिडेट करते हैं हम सिस्टम को, दिस नसल नंबर वर्सेस रेनॉल्ड नंबर। जब भी हम व्हेनेवर वी आर स्टार्टिंग आवर एक्सपेरिमेंटल सेटअप, वी वैलिडेट आवर एक्सपेरिमेंटल विद द ऑलरेडी स्टैंडर्ड रिजल्ट्स अवेलेबल इन द मार्केट। तो ये डाइटस वोल्टर इक्वेशन से हमने हमारे सेटअप को मेजर करा और वैलिडेट करा कि इट्स नाउ ओके फॉर द एक्सपेरिमेंटेशन। फिर हमने जो भी जनरली वी आर यूजिंग नसल नंबर एंड रेनॉल्ड नंबर, इसमें हम एक्चुअली कितना नसल नंबर बढ़ रहा है वो हम देखते हैं। एंड विल डेवलप द कोरिलेशंस आल्सो। हमने इसके लिए हीट ट्रांसफर कोरिलेशन डेवलप कर रहे हैं। एक जनरलाइज हमने कोरिलेशन डेवलप कर लिया। यदि भोपाल में किसी को सोलर हीट एयर हीटर लगाना है तो वो अपनी उसमें वैल्यू पुट करेगा और उसको एक डिजाइन उसको आ जाएगा। श्रीनगर में डिजाइन करना है, हैदराबाद में डिजाइन करना, तो कोरिलेशन अवेलेबल है कि उससे इतना हीट ट्रांसफर मिलता है। So these are the data for plate. Now these are the result between Nusselt number and Reynolds number. कितना Reynolds number पे कितना Nusselt number बढ़ रहा है। और these are the effect of artificial roughness height, artificial roughness pitch and wedge angle. तो ये हर पैरामीटर का इफेक्ट यहाँ पे दिखाया है। Now here, now we are developing the correlation for the all parameters also. हमने एक correlation develop करके दिया है। इस correlation में you fit your value and you get the Nusselt number. Suppose we are testing 20 to 25 plates or artificial roughness. Now we are getting Nusselt number, and this is the correlation for two parameter. Nusselt number A RE raised to the power this. Then second. Then here we are adding one more parameter. This is E by relative roughness height. We'll get this. You fit the value of E by DH, you fit the value of Reynolds number, you get the Nusselt number at different value. Then we added relative roughness pitch and wedge angle also. With this, you get the Nusselt number. Say this is the final correlation for the Nusselt number, and here the regression coefficient is 0.85. तो आप इसमें अपना रेनॉल्ड नंबर की वैल्यू डालिए, ई बाई डी एच की डालिए, पी बाई ए की डालिए, आपको अप्रोक्सीमेटली पता चल जाएगा कि हमको इतना नसल्ट नंबर मिलेगा। सेम वी हैव प्लॉट द प्रेडिक्टेड वैल्यू वर्सेस एक्सपेरिमेंटल वैल्यू कि हमारे डाटा किस रेंज में, दिस इज अंडर प्लस माइनस इस रेंज में। ठीक है। विल सेम डेवलप कोरिलेशन फॉर फ्रिक्शन फैक्टर वर्सेस रेनॉल्ड नंबर, then friction factor versus Reynolds number relative roughness height, friction factor versus Reynolds number relative roughness and P by E. This is correlation for friction. This is final correlation for friction factor. So we have developed two correlation, one for Nusselt number, another for friction factor for our solar air heater at Manit Bhopal. We have these two correlation and we can fit the value Reynolds number. We directly get the value of friction factor and Nusselt number. Now, the final concluding remarks are, among all the renewable energy sources, solar energy is the most important source of energy, which is easily available throughout the year and exhaustible from the nature. Now, artificial roughness can bring about sustainable enhancement in the thermal performance of the solar air heater. Now, future of solar energy, plastic, water and air heating, then low cost, low weight, then coupling of advanced vapor absorption cycle with high temperature collector, required less collector area, then power generation, concentrating PV system. So these are the future of the solar energy. These are some reference from where I taken all these things. Thanks.
Huh. Thank you, sir, for a very good lecture on this thing, applications of solar energy. Yeah. So I have some questions. Then I'll then ask some students if they have some any queries. So, sir, can you tell me? You were talking about wind velocity. How do you calculate heat transfer coefficient on account of wind velocity?
Actually, in our system, we are not taking this part of wind velocity.
Okay,
Actually,
you are not taking this.
yeah, this parameter we are not including this wind parameter.
So
But
wind,
there is definitely, with the help of this wind speed, this temperature is reduces. This is
Mm.
definitely,
Because
but this parameter is not affect our heat transfer
okay,
actually.
but one thing I'll tell you now, because you are having losses if you use a solar water heater or solar air heater, you are having losses on
Yeah,
account
yeah.
of
We have
intense.
three types of losses in solar heating
Yes,
system.
sir.
One is top loss, another is side loss, and one is the bottom loss. Three types of losses.
Acha.
When we are going for analytical purpose, we are
Okay,
doing analytical analysis. We
okay,
are including all the losses for the analytical purpose. But
okay.
when we are going for experimental, these
Obviously,
losses are,
you will not.
yeah,
You will
yeah,
do measurements and other things.
yeah, yeah, yeah.
So, how many thermocouple measurements you have taken? How many thermocouples you have attached in this
Actually,
typical setup?
we I have in our experiment at that time 15 years back we are attaching 18, but nowadays we are also calculating the local heat transfer coefficient.
Okay, that's
At
fine.
that time we are calculating the average heat transfer. That's why we are using only few 15
Okay,
to 18. But
okay,
nowadays we are attaching 100, 200, 300 thermocouple wire on the plate.
okay, sir.
And because of this data logger, we are very easily maintain the record of the temperature.
So, how many channels can it take? How many thermocouple readings can
Now,
it
no,
take?
in this data logger, we have 50 channels, 100 channels, 200 channels. It depend on your application also.
Okay, sir. So, you were talking about artificial roughness. So, what
Yeah,
is the how do you choose the height of this roughness?
yeah.
What
This
is the
depend on
typical
your
height of the roughness? What is the typical
this
height
is
of the roughness?
actually depend on the Reynolds number. There is a
Okay,
one correlation available in book. With
okay.
the help of this, this is totally depend on the Reynolds number actually,
Hmm.
the height of the roughness. If you increase the height of the roughness, then friction factor is also increased. Our
Okay,
purpose is to enhance the heat transfer and reduce the friction factor. This is our main optimum criteria for this solar air heater.
okay. Okay. So how do you gauge how do you assess the performance of your this thing? So if somebody asks some your
Yeah, we have data of smooth collector also, and
okay,
we generate data of artificial roughness. Then we'll compare.
okay,
Suppose in smooth at the Reynolds number 10,000, Nusselt
okay,
number comes around 40. In
okay,
artificial roughness, Nusselt comes about 60 to 70. And
okay,
we are calculating thermal efficiency also for the
okay,
smooth collector and the artificial. Then we'll compare how much temperature rise is there. So we are getting around 15 to 20-degree rise temperature in solar air heater with the help of artificial roughness.
okay, sir. Sir, can't we? How do you take pumping power if you use a blower in the case of an air heater
Yeah,
in the efficiency
there is a lot
parameter?
of calculations are there. We are considering this pumping power. There is some factors are there. Directly we take this factor and
Okay,
we multiply this factor for calculating the pumping power. There are many relations are given in the market for taken this pumping factor, because this is the major part. From pumping, you are this friction factor is increasing actually.
okay, sir. Sir, how do you choose the spacing of this artificial roughness? Na? You were talking about wedges and how do you choose
This
that?
is very important. But in market, there are thousands of paper are there for spacing between the artificial
So what
roughness.
should be the
But
minimum
most of the
spacing?
time, they are optimized. Now, most of the researcher optimize that P by E artificial this roughness pitch is around 10 is the best P by E. They are optimized. Lot of work is already done in this field, but they
Okay,
are optimized. Py is around 10 is the
okay.
giving best result in any type of roughness.
Okay, so actually these some of these questions were sent by my students. They have texted me these
Yeah.
questions. That's why I'm asking you
No,
because
no problem, no problem, no
they were
issue.
having some issues with the audio of the systems, so they could
You
not
give
ask.
me my email also. You have to students if
Ah,
they want any correction, if they want any research, if
okay.
they want to study in this type of field, I will definitely guide them. No problem.
Actually, some of the students at present are from MTech Thermal Engineering.
Ah, yeah,
Yeah,
yeah, yeah,
they
yeah.
have already taken this course on solar energy. You know?
Oh, this
They have
nowadays it's very important
they have
part. Yeah,
studied these solar thermal collectors and other things.
that's why I am showing one case study of solar for PV system also.
Okay, okay, okay.
They can go for PV system design of their institute also, their library also, their house also. This is a small thing they can know about the solar energy. This is
Mm.
now because our future is for solar and wind energy. So
Actually,
you know the basics of this solar and
because
wind energy.
fossil fuels are exhausting. We have
Yeah,
to look
yeah,
for
yeah,
some alternatives, and it's a clean power, clean energy source.
yeah, yeah. This is clean energy.
Clean energy. Still, let me try to check whether anybody else is online. Hello, anybody wants to ask any question? Ah, one participant.
Okay.
Hello, you can ask the question. Hello.
Good evening, sir.
Yeah, yeah.
And
Good evening.
sir, I am Rajbir Singh, mechanical undergraduate at NIT Srinagar.
Oh, very good, very good.
Sir, I wanted to ask that in solar energy collectors, you discussed that we convert the solar radiations into thermal by converting them into some fluid.
Yeah. In water heating, we are using fluid water, and air
Yes.
collector, we are using
Yeah,
air.
yeah, sir. So in fluid, you mentioned water. Can we use any other special kind of fluid for that case?
No, in some cases, for this, we are using oil also. In oil also.
Yes, yes, sir.
Because suppose we want temperature above 100 degrees centigrade, at that time we can suppose solar stoves are there, solar cookers are there. In some places, some researchers, they are using oil also, because our temperature they are required 100 degree 200 degree centigrade temperature, so they go for oil also, oil.
Yes, sir. Thank you, sir.
Anyone else? We can. Anyone else? Amir, you want to ask anything? Hello. I think he's just texting, but I don't know.
Adnan,
Can
you
we have?
give my email to your students also, you know,
Okay, sir.
so
Okay,
they
sir.
can ask if they have any question at any time. I will reply them. You know, no
Okay, sir.
problem.
Okay, sir. One student has raised hand. Amir, you can ask the question.
Good evening, sir.
Good
My name
evening.
is
Hello.
Amit Kubar.
You go ahead
I am
and
a
ask the question.
research scholar at NIT Srinagar.
Oh, very good, very
Thank
good.
you for the talk. It was a very nice
पूछिए
talk.
question.
I just wanted to ask
I don't
for
know. Again, I
conventional
was
PV
sitting na.
Please
systems.
speak loudly. Your voice is not coming.
Sir, I just wanted to ask a question about conventional
Chali,
PV.
anyway, they are
Speak
having
loudly.
some
Sir,
connectivity issues.
hello, sir.
So
Hello.
anyway, thank you, sir, for a
Hello.
very nice presentation of this thing, application of solar energy for practical purposes in solar air heaters and solar water heaters. So in fact, this is our future. This is our future because we have to look for some alternatives because fossil fuels are fastly depleting. So thank you once again. On behalf of mechanical department and organizing committee of this ATAL FDP, are highly thankful for delivering this excellent talk. So we're looking forward uh, to hear from you. Okay,
Okay,
ji.
thank you, Adnan,
Okay,
and
okay, ji.
thank you to all participants for listening this lecture very nicely. Okay,
Okay,
thank you
ji.
very much.
Okay, ji. Thank you, sir.
Thank you, sir.